Good morning everyone. I'll be talking about 3D printing in ophthalmology. No financial interest to disclose. What is 3D printing? It's a technology where physical objects are created from digital files. It is also called additive manufacturing, where each layer are deposited one above the other. Coming to the process of 3D printing, let us take the FDM modeling, which is also called as fusion deposition modeling. First, you have to design a file using the CAD software in a computer, after which it is converted into a .stl file, also called as slicing, which is readable by a 3D printer. You input this file via a pen drive to the 3D printer, which prints the file. After printing, the parts are processed, and finally you get an object. There are different materials used in 3D printing. PLA and ABS are the most commonly used material. PLA is biocompatible but brittle. ABS is ductile. You can also print using titanium and stainless steel materials. There are two methods of 3D printing. One is called extrusion, where materials are printed using a heated nozzle. The other is called sintering, where you use laser light to harden fine layers of powder or liquid. Each layer is hardened above other, getting the final product. Here you can see the laser used to make a product, and then it is processed. Though there are different types of 3D printing available, we should know about few types such as SLA, which is used for models, FDM used for prototyping, inkjet technique used for bioprinting, and SLS technique used for metal instruments. Why should we know about 3D printing? It's a disruptive technology. Just like how smartphones are changing the world around us, 3D printer is also changing a lot of things. 3D printing is used in education to help teach the students spatial orientation better with a 3D printed object. It is used in architect. It is used in construction. Already in China, they are 3D printing houses in a single day. It is used in aviation, where you make 3D printed engines which are less weight. They also make less weight fuel nozzles, saving millions of dollars. In automobile industries, more than 8 major companies are 3D printing lightweight, durable cars. In the future, most of our cars will be 3D printed. It is also used in food industry to make cookies. Already, these food 3D printers are marketed in US. It is also used by NASA to print most of their missions after going to outer space, so they don't have to carry most of them. The lunar printing project is another project where they are planning to print using a laser technology on the surface of the moon. In dentistry, more than 90% of our crowns are 3D printed nowadays. In healthcare, though 3D printer was introduced very long back in 1990s, where we started printing anatomical models, it took nearly 20 years for us to start making implants. Dr. David A. Zoff from the University of Michigan has made the first bioabsorbable airway model, which is used to treat babies with tracheobronchomalacia to prevent collapse of these airways. Dr. Liu Zonjian has 3D printed a vertebra in the year 2014 to implant to an 8-year-old boy. Now more than 30,000 procedures are being done with 3D printed titanium hip implants. It is used to make functional prosthesis nowadays. So this is made as an open source project where you are able to make functional prosthesis under $100. Anyone can download these files and print them. And they are making a lot of difference in the world of these small children who has amputated limbs. And these are functional prosthesis. Dr. Anthony Atala from Wake Forest Institute 3D printed the urothelial cells on a scaffold and implanted them to bladder disease, end-stage bladder disease patients. This opened the healthcare industry for bioprinting. He did it in the year 2006. Now we are able to 3D print most of the organs, and they are able to 3D print vasculature, which are used for cardiovascular surgeries. They are also starting to 3D print expansile vasculature around structures such as heart and alveoli. It is still in the research process. In ophthalmology, 3D printer is used for making cornea, lens, retina, accessories such as prosthesis, orbital implants, adapters, and surgical planning and teaching. I will cover most of them briefly. Here you can see the Ahmed Atiyah's 3D printed smartphone microscope adapter. This has been already discussed by Dr. John. It is used to capture the surgical videos attaching to the side scope. The oDocs Fundus camera is the first open source smartphone based retinal camera. Anyone can download these files from the internet and 3D print them. Here you can see all the parts being 3D printed, and these parts are assembled like this, and after fixing a phone, just with a smartphone and a 20 diopter lens, you can capture fundus photography even in a camp or a rural area. David Mayung from California has also 3D printed an adapter to capture the fundus photograph, which is attached to an iPhone, and you can see here the beautiful image, fundus image showing the macular edema. They have also made 3D printed smartphone slitlamp microscope, which can be attached to the smartphone, which helps us capture the slit image of the anterior segment of the eye. Dr. Andrew Bastow has 3D printed a small adapter which can be attached to a smartphone, which can be used for screening lot of people in Africa for fundus pathologies such as glaucoma and other retinal pathologies. And these patients are referred to the main hospital to treat them further. And 3D printer is starting to make change in the community also. It is also used to print surgical WETLAB models. Dr. Prashant has 3D printed a low-cost reusable surgical WETLAB model. I'll be discussing about this in the next presentation. We can also use 3D printing technology to reproduce orbital dissections, which can be used for teaching a lot of ophthalmology students. Here you can give different colors for the veins and arteries and nerves, and these models can be used anywhere. It can be used in classrooms and also at home. They have also 3D printed orbital models to help trainee perform lateral wall decompression. It is printed with PLA material, which has the same consistency as that of the bone. Here you can see a hole which is created in the inner table of the greater wing of sphenoid to expose the dura. It is very difficult to visualize the uveal melanoma. So once from the CT scans, so once you 3D print these structures, you will be able to see all the uveal melanoma tissue in a better manner. So we can direct the radiotherapy and stereostatic radiosurgery in a better manner. Dr. Sung from Korea has also 3D printed the orbital OCT of the retina. So this helps in understanding the adhesion and tractional points between the ERM and retina, helping the ILM peeling better. Dr. Koltus from New York has designed a blepharoplasty forceps. He has hand-drawn it and given it for 3D printing. He got 20 forceps 3D printed and gave it to some of his friends and colleagues. They have used this blepharoplasty forceps and given a lot of inputs. And these inputs are used to make the final blepharoplasty forceps. This is called crowdsource project. So here you can see we use the 3D printing technology to create an instrument from scratch within weeks. Dr. Navjas from Canada has also 3D printed transconjunctival vitrectomy trocar-cannula system. It is using the ABS thermoplastic. It has a few drawbacks such as it has blunt tip, irregular wall thickness, less mechanical strength, and absence of the locking mechanism. And while trying to insert it to the pig's eye, one of the cannula broke. We can correct these with advancements in 3D printing and using some other methods of 3D printing. Dr. CANABRAVA, who is a Brazilian ophthalmologist, has also 3D printed a pupil expander. He has presented this in the ACRS 2 years back and won the best video award. You can use this 3D printed CANABRAVA'S ring to expand pupil by 7 mm. Binfran from China has also compared 27 orbital reconstructive surgeries, which is used 3D printed molds, with 27 cases using conventional technique. He has found that 3D printing predicts precise fracture zones, personalized surgery with better outcome. It has also been found that it drastically reduced the surgery time, improved accuracy and safety of the surgery. In LVPI, they have used 3D printed assisted patient-specific implants, which is implanted in the basin of the inferior orbital fissure to allow recentration of the migrated implants kept in anophthalmic sockets. Zhao et al. Has used various morphologies of the anterior corneal surface to teach rigid gas-permeable contact lens fitting. In South Korea, they have started to commercialize the 3D printed prosthetic eyeballs. They use the digital light processing, which use ultraviolet rays. They are able to produce more than 150 customized prosthetic eyes in a single day. Lexus, apart from 3D printing customized spectacles, they have also started to 3D print their glasses. They are able to make this via droplet technique. Here you can vary the refractive index of each point of the lens, making customized lenses, and it doesn't need any polishing or post-processing. It has also been used to 3D print customized spectacles in patients with facial deformation. PUPIL, which is an innovative braille puzzle, can also be 3D printed. So here you can see different parts of the fish, which is separated into different parts with embossed letters of braille, which can be used by the blind children to assemble them. They've also 3D printed lens. They've 3D printed and compared the first posterior chamber intraocular lens, which is the Ridley's posterior chamber lens. They have found that though it was not processed in any manner, they found that it had a penetration of 75% of light. But it has other problems, such as while comparing the interferograms of the anterior and posterior surface, there was a significant surface roughness with micrometric irregularities. It has been also shown that unpredictability of the anterior and posterior radius of curvature of the lens printed, and there was variation of refractive index of the printed lens. But with advancements in technology, we will be able to produce a foldable posterior chamber intraocular lens in the future. Coming to bioprinting, Dr. Conner from the Newcastle University has already bioprinted the cornea. He was able to bioprint only the corneal stroma, which can be used for DALK surgeries. He used a bio-ink which contains live stem cells. First, a digital model of the cornea is obtained, and it was then used to bioprint using the bio-ink in an inkjet printer, and then it was put in an incubator. Here you can see how it is bioprinted, and it was found that the viability of the cells were very good at day 7. Here this diagram shows the keratocytes of the cornea. Precise Bio is also a new North Carolina based startup which has 3D printed the cornea, and they have already finished the animal studies where they did the dissect surgery, and in the future they may also produce the fully functional cornea. They have used a 4D fabrication technology. Korean researchers has also bioprinted a cornea derived from decellularized extracellular matrix, which is used as a substrate to print the corneal live stem cells. Indian startup has also bioprinted the cornea, which is called Pandorum Technologies. They have used a special hydrogel with specialized stem cells to bioprint the cornea. They call this the liquid cornea to help treat corneal wounds and perforations and therapeutic applications. Scientists have also bioprinted the retinal ganglion cells and glial cells, and they found that the viability was very good. But we have a long way to go to bioprint the complex retina. In Arvind Eye Hospital, we have 3D printed the eye drops helper, the eyeball model which is used for teaching residents direct ophthalmoscopy, indirect ophthalmoscopy, and slit lamp examination with 90 diopter lens. So all of them can practice these models. We have bioprinted the microscope simulators which can be used to help counsel the patient before phaco surgery on what light they see, and we have also printed glass dropper. So I would like to conclude my session by saying that 3D printer is not just a technology to see and wonder, but a tool to realize our ideas and make them into useful products. Thank you.